So now we're going to move on with absolute value inequalities, but instead of becoming an and inequality, these ones are all going to become or inequalities. And the way to tell that, the trick, remember on the last one we said if it's less than, it's going to become an and. This one is going to become great or if the absolute value is greater. So right here it says the absolute value is greater than 18. When I see this greater, I know it's going to become an or inequality. The absolute value is great or than 24. And the absolute value is great or than 20. So all three of these inequalities are going to become a compound or inequality. So in this first problem, remember inside these absolute value bars, in order to get 18, I can take the absolute value of positive 18 or I can take the absolute value of negative 18. So inside the absolute value bars, that 3x, I can have greater than 18. And on the left side, I keep my inequality the same and I put a negative 18. The way that I know that this is going to be an or inequality is when I cover this up in the middle, negative 18, it says is greater than positive 18. Is a negative greater than a positive? No. Well, if it's not true, that's why it's not an and. There isn't a number in between where 18 is bigger, or negative 18 is bigger than a positive 18. So if it's not true, we're not going to fill in the middle. It's actually going to become an or inequality. You can still solve this exactly the same way that we've already been doing. To get rid of a multiply 3, I have to divide 3. And what I do to one side, I have to do to all the sides. So I end up with negative 6 is greater than x, which is greater than positive 6. Again, at this point, to figure out whether I can leave my answer exactly like this as a compound inequality, or if I have to split it, the trick is cover up what's in the middle. If it's true, I can leave it as it is. But if it's not true, I'm going to have to split it apart. So if I cover this up, this is saying negative 6 is greater than positive 6. Well, negative 6 is not bigger than positive 6. So if it's not true, that's when I'm going to have to split it apart into two separate inequalities. If I take this part of the inequality right here, it's saying x is greater, bigger than 6. But if I cover up this side and I just look at this inequality right here, this is saying negative 6 is greater than x. So if this is saying negative 6 is the one that's bigger than x, then that's the same thing as saying x is smaller than negative 6. So when I go to graph this, I am saying x is less than the negative 6 or x is greater than the positive 6. So on my number line, I need to start with one further. So I'm going to start at negative 7, negative 6, negative 5, negative 4. I'm going to go ahead and put that dot, dot, dot. 4, 5, 6. I need to go one further the other direction, so I'm going to go to 7. I'm going to have circles on positive 6 and negative 6. If I look at this inequality right here, I have x is greater than a positive 6, so I should be going to the right. And if I cover that up and I look at the other part, this is saying x is less than negative 6. So from the negative 6, I should be going to the left. That means if I plug in any number to the right of 6 into this, it should actually work. But I could also plug in any number to the left of 6, and it should negative 6, and it should also work. So negative 7, negative 8, I could plug in negative 8 into this inequality. Instead of x, I can plug in negative 8. 3 times negative 8 is negative 24. Well, negative 24 isn't bigger, but remember it's in the absolute value. And the absolute value of negative 24 is 24, and 24 is greater than 18. So it's the same concept as we move on, except instead of just a one-step inequality, it's going to turn into a two-step. So everything inside that absolute value bar should still be greater than that 24. But remember, inside the absolute value bars, I can have a positive or a negative 24. I leave my inequality sign the same on both sides. And I'm just going to start solving this inequality. To know whether it's going to become an and or an or, remember I just need to cover up what's in the middle. In order to come together and be in the middle, it should be true. If it's not true, I need to separate them and it's going to become an or. So in this problem, it's saying negative 24 is bigger than a positive 24, which is actually not true. If it's not true, my inequality answer needs to become an or. And now we can solve it the same way we always have. To get rid of a negative 9, I add 9. And what I do to one side, I have to do to all sides. So negative 24 plus 9, I end up with negative 15 is greater than, in the middle I still have that 3x, is greater than, and over here I end up with 24 plus 9, which is 33. My final step, I have to divide by 3 on all sides. Negative 15 divided by 3 is negative 5, is greater than x, and which is greater than 11. Remember, to know whether I can leave my answer exactly like this, I have to cover up what's in the middle. If I leave it, it has to be true. Is negative 5 bigger than a positive 11? Well, no. So if it's not true, I can't leave my answer like that. I have to split them. So over here I have x is greater than 11. But if I cover up this side, the other inequality on this side, this is saying x is less than negative 5. So my final answer is x can be anything less than negative 5, or x can be anything greater than 11. So to represent that on the number line, I would need negative 6, negative 5, negative 4. A lot of numbers in between, and I'm going to pick back up at 10, 11, and 12. The 11 and the negative 5 are the two numbers that are part of my answer, so that's where I'm going to put my circles. And remember, back up in this inequality, this is saying x is smaller than negative 5. So from negative 5, it's going to go to the left. Remember, you do need your arrows because it's going to keep going and going and going. It can be negative 6, negative 7, negative 8. And over here, this is saying x is greater than the 11. So the last problem we're going to work on, the only thing that makes this a little bit more complicated is I have a negative best friend. But really, nothing in this problem is new. It's combining all the things we've already done. So everything inside these absolute value bars, I can take the absolute value of a positive or a negative 20 and still get 20. So I have negative 2x plus 4 is greater than or equal to 20. On the left side, we have to put our negative 20. And now we're going to solve this inequality exactly the same as we always have. Remember, if I cover up what's in the middle, it should be true. If it's not, it's going to have to split at the end. This is saying negative 20 is bigger than positive 20. Well, that's not true. If that's not true, remember that means our answer needs to split and it's going to become an or for our final answer. The extra step for this one is my best friend is negative. And remember, when my best friend is negative, I'm going to have to flip those inequality signs for my final step. Everything else is exactly the same. To get rid of a plus 4, I have to minus 4. Over here, same sign, add and keep. I get a negative 24 is greater than or equal to a negative 2x, which is greater than or equal to 16. For my final step, I have to get rid of that negative 2 by dividing a negative 2. That means over here the two negatives are actually going to cancel out. So I end up with a positive 12 is less than or equal to x, which is less than or equal to negative 8. Remember, to know if I can leave my answer exactly like that, I have to cover up what's in the middle. In order to leave it, it has to be true. Is 12 less than negative 8? Well, that's not true. So if it's not true, we have to split our answer. So over here, this is saying x is less than or equal to negative 8. But if I cover up this side and I focus on the other inequality, this one is saying x is actually greater than or equal to a positive 12. So when I go to graph this, I need to start with one further to the left from negative 8. So I'm going to start with negative 9, negative 8, negative 7. Before the 12, I need to pick back up at 11, 12, and 13. I'm going to put circles on that negative 8 and that positive 12. And because they both have the line underneath, I'm going to close them in. And right here it's saying x is greater than the 12. So from the 12, I need to go greater. Or x is less than the negative 8. So from the negative 8, I need to go less. So remember, with absolute value inequalities, if the absolute value is less than, it's going to become an and. If the absolute value is greater, it's going to become an or inequality.